I'm very glad to be here to share our research work, progress, development, and deployment in the area of reconfigurable maintenance robots. And my appreciation and thanks to Zhejiang University to provide this opportunity for sharing. So SUTD is a public university in Singapore that focuses on technology and design. I'm a professor. Being part of it, my research focuses on elements of robotics and bringing closer to elements of design and finding a synergy between these two areas. So my lab at SUTD, Robotics and Automation Research Lab, focuses on three major areas of research thrust. One, design of robots, which almost every single robotics lab does. So in my lab, the critical focus is on reconfigurable robots, robots that have transformative properties to change from one form to another. The second area that we focus is design for robots. There is very few work, and in fact, we are the pioneers in this area, to look into design of spaces and products for the robots. So here we are not designing robots, but designing spaces and objects that will be used by robots, considering the abilities and requisite capabilities of robots. Imagine a train station that is robot friendly. Imagine an airport that is robot friendly. So here we have architects, urban planners, and interior designers that work with roboticians to develop these future built infrastructures. So the third area that we focus is design by robot. So we design by robot, we focus on AI toolset that can help automate the process of design of robot and design for robot. So here we dig into and build upon the last 30-40 years of literature, be it academic and patent, for the AI system to arrive at optimal robotic design solution, and also build spaces that can be inclusive and friendly for robots. So collectively, we bring together elements of design of robot, for robot, and by robot at SUTD, and probably the only lab to do so, delivering outcomes beyond robots. So the scope of this presentation will focus on reconfigurable robots, and these are robots that have ability to shapeshift, change from one form to another, either to overcome difficulty in the terrain they are navigating, to move in a complex environment, or to perform tasks that are difficult and complicated. Often robots perform tasks from industrial setting to service setting, dealing with situations that has multidimensional complexity. So I will take you through an example of how at SUTD we focus not just on making a reconfigurable robot, but also a design process that enables the same, right? So in this specific case of Scorpio, we were tasked to develop a robot that can roll, crawl, and climb wall in the context of an urban reconnaissance mission. So it's a very difficult and challenging research problem because there is no precedence. Simply, there is no example for us to leverage upon to develop a robot that can crawl, that can roll, and climb wall. We look to nature. Nature has been an encyclopedia to learn for principles and guidelines to develop a robot platform for many problem statements. And here for us, we look to nature for inspiration. We not just got one, but we got 8 different species that can crawl, roll, and climb wall. So here is one of the species where we built upon our design, and the species is called Sebranus reichenbergi. It's an endangered spider species only found in the deserts of Morocco. So we looked into this as a source of inspiration to build models that can help us to develop platforms, robotic platforms that can achieve rolling, crawling, and wall climbing. So what you see here is a rolling, crawling, wall climbing robot that is less than 10 centimeters in rolling diameter. It has capabilities of intelligence to switch between these tasks. So if the robot enters a staircase, the robot will curl up and roll down the staircase. If it's traveling on flat terrain, the robot will curl up and roll, because in a flat terrain, rolling is much faster than crawling. If it's moving in a cluttered terrain, then the robot will crawl. So it's not just about bio-inspired. So with our research effort, we look into both the design process that enable an end outcome and the end outcome itself. And our focus has been always on configurable robots that are multifunctional and can solve complex and meaningful problems. The next example is another intriguing one that targets a challenging task of cleaning. Many of you may have seen floor cleaning robots that come in different shapes: circular, square, rectangle, D-shaped, and so on. So here in SUTD, we are developing a robot for the first time that derives inspiration from Tetris, the brick game that we all know. We have now mobile app. In the earlier days, we had handheld game controllers that is based on Tetris. What you see is what you see in this video is a commercial robot that has a lot of difficulties, and the company has sold over hundreds of thousands of units, but it has numerous difficulties accessing places. When it comes to cleaning, is about area coverage, is about accessibility. So here with our H Tetro platform, the robot uses type of sensors, actuators, but is able to change shape to maximize the area covered. So with this class of robots, we have different autonomy levels equipped with a wide range of sensors, from 3D LiDARs to infrared cameras to 2D LiDARs, and so on, and also scales from residential scale to a commercial scale. What you see here is the quantification of the performance of the robot. With a commercial robot, the robot now have difficulty to cross over to other side, and the area covered as observed by an overhead camera is less than 30%. Whereas with H-Tetro, the robot assumes the shape of I. It even assumes shape of L underneath the chair to cover the area, passes over to the other side, and achieve an area coverage of over 95%. So in this research work, we have explored problem statements in N-Ominos. So here you see 4 blocks. We have built robots that has 5, 6, 3 is configurable, and also robots, each of these unit that can expand and compress by itself. The class we call pleomorphic, where each class is able to expand and compress. Also, for commercial applications like logistics, you can have many of these robots put together to build a giant robot. By doing so, the robots are now scalable for a wide range of application scenarios. It's not just about the autonomous ability, it's also about the ability of the robot to So in this specific case, the robot is simply tiling the given flow, and by doing so, achieving 100% area coverage. In a typical game, when a screen is tiled up, the player loses the game. Whereas with our robot, it maps, it generates the tiling set, populate the entire area, synthesize the tiling set, and achieve complete area coverage and wins the game of cleaning. So here we have optimized the algorithm to maximize for the area coverage and minimize the number of times the robot reconfigures. so that is also energy efficient. So our work in reconfigurable robots, shape-changing ones, spans beyond just horizontal floor. As you can see with the case of S-Tetro. With respect to cleaning, the problem statement is often centered on floor cleaning, but here in SUTD, we took upon the challenge of cleaning staircases. As staircases are inherent and essential feature in every built environment, and there are multiple of them, and cleaning them are more difficult than cleaning floors. So here we have developed S-Tetro. Is a configurable robot that is capable of cleaning floor with wheels and by climbing, like use of legs to climb. The robot is autonomous. It is equipped with full suite of sensors to detect and classify different type of staircases, like straight staircase, left-leaning staircase, right-leaning staircase, spiral staircase, and to generate appropriate control primitives to climb and clean them, demonstrating the worth of reconfigurability. So we have gone beyond floor and staircase to also tackle problems with facades. With cities like Singapore, cities like Hangzhou, we are seeing increasingly more and more buildings that has glass facades. Maintaining them are very difficult, and there are products in the market that targets glass facade cleaning, but the biggest challenge is the ability of the robot to get over positive or negative obstacles, like the curve that you see here. So commercially available robots have to be manually moved from one panel to another, as they do not come with the ability to move between panels by themselves. So here we have developed Mantis. The two cables that you see are only for safety, but the robot uses the principle of impeller suction to adhere itself to the glass panel. The robot is capable of moving from one panel to another all by itself and implement autonomous path planning approaches like zigzag and spiral to achieve area coverage. Again, the power of reconfigurability. So we have configured the fundamental principles that empower Mantis robot, the facade cleaning robot, to develop another robot platform that can inspect and clean the external surfaces of aircraft. So again, aircraft cleaning is a tedious process and a dangerous and laborious one in many people, and that also requires a high degree of precision and accuracy. So here we have scaled up and configured the fundamental enabling capability of the Mantis platform to develop another robot that can clean the external surfaces of aircraft. So not just about small configurable robots in large scale can play a vital role with huge advancement in autonomous cars. We are developing robots that can sweep pavements. Pavement sweeping is again a labor-intensive and difficult work process. So at SUTD, we are developing an autonomous pavement sweeping robot that is also capable of compressing and expanding. Compression and expansion in these robots is very important. That enables them to be versatile. So imagine crowd of people walking, running, jogging, bicycling, and these robots can compress and allow people to pass. It can be a wheelchair user, and the robot is capable of sensing the environment and compress from any specific direction to allow people to pass. A number of capabilities have been demonstrated with the platform, where the robot can move forward while compressing and waypoint navigation, path planning to achieve maximal cleaning in a given area, and also perception of the environment given is outdoor. So we have passed initial trials in our campus, in our SUTD campus, and now we are working with Singapore's National Environmental Agency for field trials outside the campus. So we wanted to go always beyond intellectual output in terms of publications. We have made huge advancement in knowledge in the scientific community in reconfigurable robotics, but we always aspire to go beyond. So my lab at SUTD has turned itself into a catalyst to inspire a series of companies that produce robots for the global markets. The very first of them is LionsBot. So LionsBot is a company that design and manufacture professional cleaning robots. And the company develops in-house capabilities all the way from mechanical design to full stack development and manufacturing of the platforms. So our robots are now deployed in variety of settings in Singapore, and several hundred robots deployed here. We have now exported our robots to over 24 countries, and they are deployed. They are helping very much in the fight against COVID, with the frequency of cleaning gone up and the number of cleaning professionals falling even before COVID. Robots such as our LionsBot and LeoBot platforms have been playing an instrumental role. The robots are configurable in nature, so they offer configurable payload options. The robot look the same, but you could configure them into a mopping robot, a scrubbing robot, a vacuuming robot, or a pull robot. So the video here will present its ability. Again, is a commercial robot that
he uses the Lions Clean app to manage his LionsBot cleaning
available for
Leo Scrub specializes in scrubbing and drying floors. Designed to prevent collisions, she comes with a full suite of safety sensors. Deployment using the Lions Clean app is easy. Being nimble, she can access narrow doors and tight turns readily. Leo Mop cleans silently and uses 70% less water than other machines. Together with Leo Scrub, they form a smart team. Leo Vac cleans both.
It's not just in cleaning domain. Configurable robots can make a huge impact in multitude of domains. The second startup company that was inspired from our lab is Oceania Robotics, a company that is now into 3 areas: marine, pest control, and landscaping. And again, they are using configurability and transformative properties as fundamental to the robots that they design and manufacture. So Oceania Robotics designs and manufactures marine robots that does ruggedized and ergonomically difficult job of hydroblasting, grid blasting, stripping, benchmarking, and beyond. So again, the robots offer configurability as the payloads can be switched from hydroblasting to grid blasting to benchmarking, and the autonomy would follow suit to be proportional to the payload that it is equipped with. So also the company provides the very first kind of autonomous grid blasting platform, and you can see the ergonomic difficulty an individual will have to perform these jobs. So when people perform grid blasting jobs, often they wear protective clothing, and there is huge recoil force that is coming from the blasting that the individual has to withstand. And here we are replacing such hazardous jobs to be done by robots, and whereas people can become robot operators and calibrating professionals for such robots. So also there is a huge impact of job transformation here. So we are looking to build on collaborations like the one we have with Zhejiang University and beyond to develop intriguing robots that will change the future and enable a better life for people through configurability as a basis principle. Thank you. I'm open to questions.
Great. Thank you very much for your super inspiring presentation. We received many questions, so I will pick 2. So for the first question, I think is very general. In the robot area, from lab to industry, how far do you think there is?
Yes. So now robotic, as a robotic professional and a scientist and a professor in this area, it's very exciting time for robotics professionals now. It's a field that is in a moment where translation between research lab to commercial world is almost on par, and that does not exist in another field all the time. I foresee that for the next 25 years, next 25, hello?
Yeah.
For next 25 years, we will witness this momentum where the transformation of technologies and even people between academia, research to industry will be is on the same plane. And that is very exciting because there will be more and more companies created with maturing component technologies, software, and new enabling technologies like the 5G, like cloud robotics, edge computing, and new materials like the exciting materials presented by the previous presenter. I see all these are factors that will drive robotics for the coming 25 years. And the translation will be on the same plane, and that is exciting time. So the effort is minimal at the moment. Is not like like a decade ago or 2 decades ago, when the papers for robotics or research work focuses on primarily simulation and low fidelity prototypes, and not anymore. So now we are all looking at high fidelity prototypes that is doing the actual job. Yeah, like the ones I presented, like staircase cleaning, facade cleaning, pavement sweeping, and then you go to most research lab, you see robots that actually does the job. And that is exciting time for roboticians and businessmen who is keen to invest in this domain and move further.
Okay, great. Thank you. So the second question, I think, is from a young student. So if I want to apply for your research lab, what kind of background do you think is the key to the robot? Is the mechanical structure or the software?
Yeah, it's a great question. So as you can see from the spectrum of work that we do, we have students that specialize in let's say mechanical engineering. We have students specializing in computer engineering that develop intelligent system, with mechanical engineers developing the structures, mechanics of the system. We have psychologists that study human-robot interaction behaviors. We have even architects, interior designers that are working with us in terms of developing spaces that can be friendly for robots, that are inclusive for robots. So especially with our research group in SUTD, we span the entire spectrum, because we study and build not just robots, but also the design process. And we believe that every expertise is needed in the field of robotics, as we are not looking at the vertical in terms of providing intellectual output, but we are looking to offer a complete solution as a product or a process or a service. Even the school that I'm affiliated with is engineering product development, and the vision of SUTD is to connect every research to meaningful product, service, and solution. So if you are intending to apply to my lab at SUTD or generic to SUTD, you are welcome, and every expertise is good to integrate, and there is a value, because translation is the key.
Okay, great. Thank you so much.